All right, let's dive into the flyweight design pattern. The flyweight design pattern is a structural design pattern that aims to reduce the memory footprint of your application. That means reduces the memory usage of your application by sharing some of the object's data with other objects. So when you have an object, we're going to see an example where we have an intrinsic data, something internal to the object that is shared with other objects, and some data of that object are external, have something extrinsic state that will be changed so the other objects can change them, right? So we're going to see how this design pattern is used to reduce the memory footprint by sharing some of the data fields of an object with other objects without recreating the object multiple times, right? In this lab, we're going to look at some scenario and how to apply this flyweight design pattern to this scenario. So let's look at the requirements. You need Java 1.8 or above, and IntelliJ IDEA makes your life easier when working with Maven projects, right? So let's get started. So you need to click on the deliverable and submission link, and then this should send you to the links to your GitHub classroom, right? So let me click on this link, and then open it up, and then go to the GitHub classroom, and then accept the assignment. All right, so accept the assignment, and then reload. So this will create a new repo for us. So go ahead and clone this repo. So copy the URL, go to the command line. If you're on Windows, go to PowerShell, and then git clone, and then paste the link. This will download the code, the repository, to your file system. Go there, and then I'm going to open it up in IntelliJ IDEA. All right, so let me grab IntelliJ IDEA and open the project. So I need to point to where this is stored. And then select the lab, and then trust, and then this should open up the project. All right, so we have the project. That's the README file for the project. So let's take a look at the files that we have. So the first thing you do is you go to the pom.xml, check the version 1.8. That means you go to change the SDK version in your IDE. So you go File, Project Structure, and then be sure to select the SDK. So here it's set to 18. I'm going to change this to 1.8. Just keep things consistent, right? 18 should work. I just like to keep things consistent with the pom.xml file. So let's take a look at the source files. So under src, we have main. So that's the code, the source code, under Java, and then the package name. This is the demo, the image element class. This is the image element factory class. So these are the classes that we have. And then that's the demo. This is basically the client or the main class. So something new here, we have resources. So that's the resources directory that contains the images. So this is a convention to store images under src main resources. And these are the test files, right? So we have all the images under src main resources images. And then we have the test here, right? So let's go back to the description, look at the problem. So we've got a developer who's working on a game where it creates a large number of background elements, objects like clouds, trees, etc. So to create a large set of objects for this game, the developer is planning to release her game on mobile. So she's worried about high or increase in memory usage, right? So although this game seems relatively simple, creating hundreds of thousands of these objects may impact the overall performance of the game, right? So she created some classes. Let's take a look at them to um, uh, place these images in an image icon, right? So this is a Java Swing application. So we're gonna import the JavaX Swing image icon. This is our image element. An image has a name, and then we have a getter to return the position. These are the external state that other objects can change. So we can change the position of the image, but the image will be exactly the same. So this is, we'll get an image element, right? If the image is not found, we can find it in your file system. Then we'll throw an exception. So we grab the image from, remember, it's under SRC main resources. So this is how we get the path, and the path is sent to us. So SRC resources, images, and these images, right? So we want to get the path, the file path name for these images. It will be returned to us as a URL, right? So let me take a look at that image element. So it's right here. So we get the path, and the path is returned as an URL. So we use that to construct an object of image icon, and then we check if the image was loaded. That's fine. If not, we're going to return files not found exception, right? And then we return it to the caller, right? So this is our demo class. The demo is going to make use of the image element and create basically the JFrame, and then the panel, and then the image icons inside it, and we'll make use or make calls to the image element and the image factory that we will see later, right? So here we create our JFrame. We set and create a panel. A panel is a placeholder for holding and storing the image icons. So if we go to the image element factory here, here we create our hash map. This will store the objects for our flyweight, the image element and the name of the elements. And then we need to implement these two methods. All right. So the first one should return a flyweight if it already exists. Otherwise, should put it into the map. Right. So if the object doesn't exist, the image icon does not exist, we're going to be storing it in this flyweight map. Right. And then we return the size. So we should be making use of thousands or hundreds of images, and we should end up with only storing 4 actual images. Because we're separating this external and internal data, right? The intrinsic state is the object itself, the images, the image icons themselves, and the extrinsic are their position, right? So we want to separate those two things. We want to store only 4 images, and their location should be stored in another object. So that way we can reuse these images over and over without creating hundreds of them, right? So this is a code completion question. So we're going to take a look at how we build this and complete the source code. So we're going to look at the second question, which is changing this later. But for now, let's just look at how to complete the code in the image element factory, right? So here we have this hash map that we want to check if a file with a given name, tree, cloud, flower, exists in our flyweight data structure, this hash map. If it does exist, we return it. If not, we will create a new one and then return it to the caller, right? So this is the hash map. We'll take a name of the file and then an image element. So we check flyweights that contains key. If it does exist, we give it the name. So let me change this from int to name. And then If it does exist, we will return it, right? So give it a check by the key. Remember, hash maps are key value pairs. So we check by the key the name of the file. If it does exist, we're going to return the actual image element, right? Now, if it doesn't exist, we're going to create a new image element, right? So this is the else. You don't need to write else because you already returned in line 13. So we create an image element, we give it the name, and then we need to put it inside our hash map, right? So again, say flyweights.put, and then give it the name, and then the image element, right? Remember, image element is the one that will create the actual image icon, right? The actual swing image icon, and then we return the image element. So just put it by the name. So remember, key value pairs in the map, and then return it. And this is super easy. Number of flyweights, you return the size of the flyweight. So we're gonna say flyweights.size, right? And really, that's it. So this will check if the flyweight doesn't exist. We'll create a new one and then put it there. Let's take a look at the demo, the client class. So we have here 4 images for the cloud, flower, palm, and tree. We have a J panel, a J frame. Create a J frame, set the title, the size, and then make sure it closes when we close it, and then create a J panel as a container, and then we add things to it, and then we set visibility true. We have this add image that would keep adding an image, but look, the X and Y are extrinsic, are external to the image element, right? So we're not storing them in our flyweights, the positions, right? So we set these things externally to the actual object. And here we have the main. So we create the main method to create an object of the demo. We're going to use the image element factory, this one, to get the flyweights, get these images. And then we will maintain a list to store those store an image elements, because we're going to keep their positions externals in another list, just the positions, not the image icon itself. And we randomly create or pick an image from these images. So store them in an array string right here in the top, right? So we have this array that contains the name of the images that we have, and then we will randomly pick a name and then add the PNG to it, because that's the extension of the file. And then we will check if it exists in our flyweight, we'll get it. If not, the flyweight will create it. Remember, if it doesn't exist there, it will create and put it into our flyweight, right? So we check here, and then we add this the flyweight to our list, and then we will be basically displaying the image name, and then the position will be incremented by 200, right? So we multiply 200 for the X and 200 for the Y. Just want to make sure that they are apart, so they don't overlap. And here we iterate through this list, and then we print their position, right, by calling the myPosition method. And then at the end, we're going to print the size of our hash map, right? The size should be 4, because we only have 4 objects, and we separated these data, right? The internal and the external. So let's run this guy. So it ran, and I need to resize it to see it, and this can be fixed later. So now we see all these images, all right? And done with the 10,000, and our flyweight is only 4, right? So these other informations are stored externally, because we separated these two states, and we reduce the memory footprint of our application, right? So let me go and run or take a look at, so this is, now it's running. Let me just close it. I guess I need to run the test. Let's take a look at the test before we run it. So here we'll test the image element factory. We'll give it an tree. We'll ask it, get it from the flyweight. We should get 1. And then if we ask for it again, we should also get 1, because it already exists. First didn't exist, created it, and then second it returned it back to us. And then here we test the image element. We give it an one that exists, tree.png, doesn't throw an exception. The other one, if we give it a wrong name, it should throw an exception, right? And then here we, similar to the demo class, the main class, except we're not using a list to store the positions, right? So we're gonna check if it exists or not in the flyweight. So randomly create 1000 and then adding them to the list. We don't need to add them. I might change that later. But this will test for the flyweight. If it's returning 4, no matter what we have thousands, we should only get 4. So let's run this test and hope for the green check marks. Right, great. All 3 tests passed. That's great. So all these 3 test methods are passing. We can also run the test in Maven. So if you open the Maven, this is what will run on GitHub. So it's always good to run it. So double click on test lifecycle, and it will build the project. This is what you will see on GitHub Classroom when you push your code, and all tests passed. All right. So we got test run 3, and then passing. Right. So let's push it to GitHub and see the auto grading. So git status. So I only changed 1 file. So I'll be adding it. You can just say git add src, or pass the whole path to the git add command, and then git status. Now it's staged. It's ready for committing. I can commit it now. Give it a message. Completed lab 7. Yeah, lab 7. And then push to GitHub. All right, so we push it to the remote, reload, and now this should kick in the GitHub action. So click on the details here and hope for the green. So it's taking several seconds to set up the environment and run the test. So green, great. So we should be getting the grade. So if we click on this, then I can filter the log messages instead of scrolling by just typing in the search logs. Let me just try this, see if it does work. So passed or pass. Great. So yeah, you search for passed, and then you should get all tests passed. Lab 7 test green, check mark, 100 out of 100, and those 3 tests were run and passed. Right? So that's how you complete the code, and then it's asking you here to change the number of created images to hundreds of thousands to experiment with how many flyweights have been created. It should all result in 4. I'm not gonna do 100,000. It's gonna take several minutes, so I'm gonna just 20,000 and run it. So right click, run the demo, and wait for a few seconds. And if I click on the Swing app, still not loading. I can use something like pack, I think, in the JFrame to see them rendering by changing that. I'll do that later. So now if I, so we get only 4, and let me just resize this so you can see it. And we get all these 20,000 images, and only 4 are stored in our Flyweight object. All right. So so that's how you implement this design pattern, the Flyweight design pattern. Again, you can experiment this and increase the numbers. All right. So make sure you edit the README file. Put your answer for question 3. Question 3 is asking you to explain how it reduced the number of objects stored in memory compared to just storing them all. Right. So you need to refer back to the idea of sharing some of the object's data with other objects by separating these extrinsic state and intrinsic state of the object. So anything intrinsic should be stored in the Flyweight. The images themselves, anything extrinsic, should be stored somewhere else, right? In other objects, like the position of these images, right? So you add the README file when you're done, and you commit it. So every edit you do, you add, and then you commit, and then you push, right? I'm not gonna do it. You have to do it. So once you commit, you should push, and this should send it over to GitHub, right? So that's how you do the Flyweight design pattern.